Alright, now we're going to graph an entire function, not just the vertex. So we have a function f of x equals 3x squared plus 12x plus 7, and it's in that ax squared plus bx plus c form, which it needs to be before we can begin graphing. So our first step, from the notes on the previous page, is to find the vertex. So remember your formula. I've got mine on my index card. X equals, now I need b and a, so off to the side I make my list. A equals the coefficient of the x squared term, which is 3, and b equals the coefficient of the x term, which is 12. So now I'm ready to put it in my formula. Opposite of b over 2 times a. So the opposite of b will be negative 12 over 2 times a is 3. So I'm using the vertex formula. Calculate this and we get negative 12 over 6. Negative 12 divided by 6 is negative 2. So I have just found, trying to find the coordinate pair where this parabola is going to turn, and I've just found the x part. Now I need to find the y part. So if we look at our notes on the previous page, it says that we need to plug this negative 2 back into the function to find the y value. And that y value is going to be what we call the minimum or the maximum, the highest point on the parabola or the lowest point. So we're going to find f of negative 2. F of negative 2. So I grab the function, and wherever there's an x, I leave it out and put a pocket in its place. So 3 blank squared plus 12 times blank plus 7. And what am I putting in the pockets? The negative 2 that we found x was. So we're putting negative 2 in here and here. Alright, now if you want to save time and be accurate, you can put these expressions into your calculator just with the way you see them, with the parentheses, the exponent outside the parentheses, the negative signs, etc. I like to calculate them mentally. Negative 2 squared is what I do first, and I get 4. And 4 times 3 is 12. And then plus 12 times negative 2 is negative 24 plus 7. Negative 12 plus negative 24 is negative 12, plus 7 is negative 5. Alright, I've just found the value that goes in my coordinate pair for y, for the output, when x, the input, is negative 2. And then I got to decide, is that a maximum or a minimum? Well, this parabola, because the coefficient of the x squared term, the number multiplied by x squared, is positive, it will turn upward like a cup. So that means this point will be at the bottom, and it will be a minimum. So my minimum is negative 5. It's the y value of that coordinate pair. And I'm going to graph that vertex right now. It's at negative 2, negative 1, 2, 3, 4, 5. It's right here. And I now want to get some values on each side of it to see the shape of my parabola, the shape of the cup. And in order to do that, I'm going to put my negative 2 for x and my negative 5 for y in the middle of this t-chart. And I'm going to find what y is when x is negative 1 and when it's 0. Two values this way, so I can get my graph going like this. And then I also want to have two values going this way. And notice I've just got a number line here, negative 4, negative 3, negative 2 in the middle, negative 1 and 0. So two values on each side of that x value of your vertex. Now I'm going to find the outputs for these. And you can use your calculator, or you can do it by hand. Let's practice using the calculator this time. Let's start with the negative 1. So here's our function, 3 times negative 1 squared, 3 parentheses, let's turn it on, 3 parentheses, negative 1, close your parentheses, square it, and then we've got plus 12 times negative 1, plus 12 parentheses, negative 1, close your parentheses. Whoops, got something extra in there. delete, -1. All right, close parentheses, and then finally +7. And I get -2. So when I put in the input -1, the output is -2. All right, let's put in the input 0. Now, in this calculator, I can arrow back up and I can type over values. So I can type over that -1 and put a 0 in. I just have to delete the negative sign. And I can type over the -1 here. Delete the negative sign, type over the 1. And now I have exactly the same function in my calculator. I still have the +7 in there. And I can hit enter without having to retype the whole thing. So when I put in 0, I got 7. All right, let's go to the other side of our vertex now and put in -3. So I can arrow over, I can insert a negative sign. If you want me to show you how to do this in class, I can. -3 we're putting in now. So just ask me if you want to. It's kind of hard to see on the video what I'm doing here. So just ask me in class. Alright, and I calculate that one and it goofed up. Let's see what happened. Oh, I got a -30 in there. Don't want a -30. Delete. Yeah, I'm going to start that one over because I goofed. Alright, so we've got 3 pocket -3 squared plus 12 times -3 and plus 7. Alright, and I get another -2. And you're going to see why that makes sense, why these two match in just a second. Alright, still got the function in there. I'm going to cover the -3's with -4's. It's the last input value I want to try. Press enter, and I get 7 again for -4. Look at this t-table. We've got symmetry. 7, -2, -5, -2, 7. These two match, and this is the center. And that's the way it should be when you're graphing a parabola. Let's watch and see why. I've already got my vertex on there. Now let's graph the -1, -2. Left 1, down 2. Now I'm going to graph this one. -3, -2. Left 1, 2, 3, and down 1, 2. Notice how these 2 points match. They're the same height. 0, 7. Don't go up or left or right. Go up 1, 2, 3, 4, 5, 6, 7. And guess what? That point also has a matching value at -4. Go left 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. And there we have it. We have the outline, the skeleton of our parabola. All we have left to do is draw a gentle curve through it. Try not to make it sharp where the vertex is. It should be a curve. And remember, our vertex was -2, -5. And you're done.